All right. Good day, my audience. Here we go again. We are still on systems of linear equation. Last time in our previous work, we were able to use row reduction to obtain the rank of matrices A and B in our previous work. Today, we are going to look at how to reduce a matrix. Okay, last time we were. Good day, my audience. You're welcome today. Last time in our previous work, we used row reduction to find the rank of a matrix. Now today we are going to put a matrix to row canonical form. We're going to learn how to reduce a matrix to row canonical form. And we're going to, that is example 2. We're going to reduce this matrix to row canonical form. Now, the method is first of all to reduce it to row echelon form. When you reduce it to row echelon form, by then you would have been able to know the the rank of the matrix. The matrices, the rows that are zeros will go out, will become zeros, and then you now reduce it further to what? Row canonical form. So the first step is to reduce it to echelon form. Then the second step is to row reduce it to canonical what? Form. So we're going to use this matrix as an example. Looking at the matrix, I would like this row, the second row, to come up and the first row to come down so that we have a leading one up there, so that we can be able to make the other ones under it zero. So the first operation there is to swap. This is row 3, row 2, and row 1. So the first operation here is to swap the rows. We have 1, 5 minus 4, 2. Okay. Here we have 2, 3 minus 1, 5. And then 3, 8 minus 5, 7. Now we're going to perform 2 operations here to remove this. The first one is our arrow 3 will be arrow 3 minus 3 arrow 1. And then arrow 2 will be arrow 2 minus 2 arrow 1. So I'm going to perform that operation there, and then I'll write down what I have inside the matrix. First of all, we have 1, 5 minus 4, 2. So we perform these operations by the side here. Arrow 3 is 3, 8 minus 5, 7. And then 3 arrow 1, you have 3, you have 15, you have minus 12, and you have 6. When we subtract that, we're going to have 0. 8 minus 15 is minus 7. Okay? Minus 5 minus 12, minus 12 is 7. 7 minus 6 is 1. Okay? Next, we're going to look at this other operation. Arrow 2 is 2, 3 minus 1, 5. And then 2 arrow 1 is 2, 10, minus 8, and 4. If you subtract this, you have 0. Subtract this, you have minus 7. Subtract this, you have 7. And subtract that, you have 1. Wow. We have two rows that look alike here. So we can just choose this one, and this one becomes a 0 row. So how do we do that? The next step is going to be, okay, arrow 3 is equals to arrow 3 minus arrow 2. Arrow 3, first of all, we have 1, 5, minus 4, and 2. And we have 0, minus 7, 7, and 1. Then this one, arrow 3 minus arrow 2. Minus 7 minus minus 7 will give us 0 here. 7 minus 7 will give us 0 here. 1 minus 1 will give us 0. Now, this is the what? Echelon form. Echelon form. This is the echelon form where we have the pivots as 1 and minus 7. Now, we go ahead now to reduce it to row canonical what? Form. To reduce it to row canonical form, I need to make this one positive 1 plus 1. So how do I do that? I need to divide through by minus 7. If I divide by minus 7, I have root 2 divided by minus 7 will give us, we have 1, 5 minus 4, 2. Okay? We have 0, 1. Minus 7 divided by minus 7 is 1. Minus 7 divided is minus 1. Minus 7, yeah, minus 1 over what? 7. Then you have 0, 0, 0, 0. Now, the row canonical form has a rule. The rule is that once we have a pivot that is 1, now that column, it is only that 1 that will be the non-zero entry. That means this one is meant to be 0, and this one on top of it is also meant to be 0. Now look at this leading one also. Under it we have zeros. So what is left for us to do to put it in canonical form is to ensure that here is 0. So what do we do there? I'm going to clean here. I'm going to clean here and look at it. So all we need to do there is to make this one 0. So that will be R1, okay, is equal to R1 minus 5 R2. R1 minus 5 R2. First of all, we have 1. Okay, let's write other one. 0, 0, 0, 0, 0, 1, minus 1, minus 1 over 7. So it is R1 that we want to change. So 1 minus, okay, let's write it out. R1 is 1, 5 minus 4, 2. Then 5 R2 is 0. 5 here is 5. 5 here is minus 5. 5 here is minus 5 over 7. Let's subtract. This minus this is 1. Okay. 5 minus 5 is 0. Minus 4 minus minus 5 is 1. 2 minus 5 over 7, that's 2 plus 5 over 7, will give us 14 plus 5 over 7, and that is 19 over 7. So what we have here is 19 over 7. So we have been able, this is the matrix we are looking for. We have been able to put that matrix C to row canonical what? Form. So this is the row canonical form of the matrix. The leading variables, the leading coefficients which are turned to 1. This one must have zeros under it and above it. This one also must have zeros under it and above it. There is no leading coefficient here. So we have this as the row canonical